In section 5, we're going to work on rewriting logarithmic expressions, which is going to involve using some rules of exponents, or sorry, rules of logarithms to expand or condense logarithms, and also utilize the change of base formula. So when we talk about base, this is our vocabulary word, this is read log base b of a. So when we're talking about the base of a logarithm, we're talking about this little subscript number here. And remember that for a common logarithm, it's a log base 10, and a natural logarithm is a log base e. Okay, so let's take a look at what we might use some of this information for. The concept of decibels and volumes of sound, so the loudness of sound in decimals, involves logarithms. So we have a sound with an intensity I in watts per square meter, that's I here, and we can calculate loudness using a common logarithm where I sub O, the zero intensity, is barely audible sound, so 10 to the negative 12 watts per square meter. So we're going to do this problem later by working with logarithms. But first, let's take a look at some of the rules of logarithms. So these rules are very similar to the rules of exponents. That's logical because the logarithms are the inverse operation to exponents. So what this basically says is I've got two items being multiplied together in the logarithm. If I could factor them apart, I could make it one logarithm plus another logarithm. So when I can factor the object of the logarithm into things that are being multiplied, right, and that's the key element here, things that are being multiplied can go into separate logarithms that are being added. Things that are being divided go into separate logarithms that are being subtracted. And when I have the logarithm of something being taken to a power, the power can come out as a coefficient. Okay, so this mirrors the properties of exponents that you've already learned, where when I multiplied items with the same base, I added the exponents. When I divided items with the same base, I subtracted. So this idea of addition and subtraction here are very similar. Okay, and the same here where when I took a power to a power, I multiplied my exponents. Here I'm taking an exponent out and I'm multiplying it times the logarithm. So part of your work is going to give you items that are approximations. And the idea when you have work like this, where they've given you specific values of two logarithms, is to use these two logarithms and these rules to make the situation you're looking at. So if I want to look at log 3 when I have 12 and 4, I know that 3 is 12 divided by 4. So I could say that this is log of 12 divided by 4. And that means looking at this rule, I could say it's the log of 12 minus the log of 4. And so that's 1.079, that's the log of 12, minus 0.602. Okay, so 9 minus 2 would be 7. 7 minus 0 is 7. 0, or actually going to be 10 minus 6 is going to be 0.4. So this becomes 0.477. Right? Equally, I could say that this is 48 can be made with 4 times 12. So if I factor the 48 into 4 and 12, then I can add the logarithm. So this is going to be log of 4 plus log of 12. And that's going to be then 0.602 plus 1.079. So that's going to be 1.86, so 1.681. Okay, and when you talk about log of 16, that would be the log of 4 squared. So that'll be 2 times the log of 4, which is 2 times 0.602, which is going to be, let's see, we'd have a 4, a 0 to 1.204. Okay, so when you've got work like this, you're looking at how you can use these numbers here to make these numbers here, what operation using these numbers can be done, either multiplication, division, or taking something to a power, and then use the appropriate rule to simplify. So practice with problems 3 through 6 and problems 10 through 12, and then come on back. So when we work on using these properties to expand logarithmic expressions, what I'm looking at here is I've got two different items being multiplied together. So when I can factor these parts into something things that are being multiplied, then I take a logarithm with the same base and I put them together by adding. Okay, so if I do the same thing here, I've got both multiplication and division and exponents. So I've got a whole bunch of extra things going on. So the first thing I'm going to do is I'm going to handle the division to get rid of the fraction. So I'll have the natural log of 6x squared minus the natural log of y to the 4th power. And now I'm going to continue to look at each of these individually to continue to simplify, because if I'm going to be fully expanded, I can't have multiplication, division, or exponents left in my logarithms. Okay, so this would be natural log of 6 plus the natural log of x squared minus the natural log of y to the 4th power. And to get rid of the exponents, they become coefficients. So a natural log of 6 plus 2 times the natural log of x minus 4 times the natural log of y. And now I'm fully expanded. So this is complete. So this was a very simple problem, and this was a little more complex problem. So the other thing I can do with these rules is I can go the opposite direction and I can condense the expression. So we can use those properties to pull our logarithms apart, and we can also use those rules to put our logarithms back together. So I had subtraction, that would have been turned into division. All right, so if I don't, now if I want to know if I'm fully condensed, what are the things I can't have? Well, I can't have subtraction, I can't have addition, and I also can't have coefficients. Okay, so up here, the things we want to get rid of are multiplication, division, and exponents. And when we're condensing, we want to get rid of subtraction, addition, and coefficients. So slightly different purposes, but that's the basic idea. So the first thing I want to do is take care of this exponent, because I don't want to get it mingled in with something else. So this is 2 times the natural log of 1/2 squared plus the natural log of x. Now I can go ahead and square 1/2. That becomes 1/4. So I'm also simplifying as I'm going along. And now these would all be things that are being multiplied together, because I have addition turns into multiplication. So I'll have 40 times 1/4 times x. Well, 40 times 1/4 is 10. So natural log of 10x is how this simplifies out to be. Okay, so remember, if you're expanding, you'll know you're complete if you no longer have multiplication, division, or exponents. And when you're condensing, you'll know you're complete when you no longer have subtraction, addition, or coefficients. Okay, so go ahead and practice that. Do problems 24 through 26 and problems 40 through 42. And then come on back for the last part of this lesson. So you may have noticed by now that on your calculator there are only 2 logarithms. So on your calculator you can do a common logarithm and you can do a natural logarithm. But then that's frustrating if you want to do a log base 4 or a log base 5. You don't have a key to do that. So the good news is the change of base formula will allow you to do any logarithm using either one of these keys. So the key element here is we're looking at the base, right? When you talk about log base c of a, we're going to work with the c and the a. And you'll notice that I can take any logarithm, matching logarithm, so log base b. That means I could do common logarithm, or I could do natural logarithm. The key here is that these have to be the same logarithms, right? I'm going to go ahead and wipe that out to keep color consistency here. So I'm going to take log base b of a, so the object of the original logarithm, divided by log base b of c, the base of the original logarithm. And by doing that, right, so using, and this is an example of using common logarithm and natural logarithm to do that, then I can actually use my calculator to do a logarithm of any base. So let's take a look at how that looks. If I want to go ahead and do log base 4 of 7, that means I could do log of 7 divided by log of 4. Or I could do natural log of 7 divided by natural log of 4. And if I had the ability to do other logarithms with my calculator, I could do any matching logarithms this way. Okay, so over here, log of 13 divided by log of 5. So you can go ahead and plug any of these into your calculator. In fact, if you want to test it, if you plug this into your calculator and you plug this into your calculator, you'll get the same number. Now, when I do this, I'm going to get a decimal, but I'm not going to bother doing that right now. You can do that with your calculators and get some practice. So go ahead and do that. Do problems 50 through 52. It's pretty straightforward. And then we'll come back and we'll solve the sound problem that we started the lecture with. So here they've given me some information, right? So what we want to look at is for a sound intensity I in watts per square meter, the loudness of I, sound in decimals, is given by this function, so I can calculate it this way, where I sub O, meaning basically no sound, is barely audible sound, 10 to the negative 12 watts per square meter. So I can put that in here. (10 to the negative 12th power). An artist in a recording studio turns the volume of a track up so that the sound's intensity doubles. By how many decibels did the loudness increase? So I know that the sound's intensity doubled. So this would be my first, right? This would be my initial sound. And if it doubled, then we'd have 2i. So that would be 10 times logarithm of 2i over 10 to the negative 12th power. Okay, so if I want to go ahead and simplify this, I can find the difference. If I want to find the difference in decimals, I could take the second one minus the first one, and I'll find that difference. So if I go ahead and write this out, I'm going to calculate this by, right, my decibel, my loudness is going to be found by taking this first one, right? I can do 10 times log of I over I sub 0. I'm not going to go ahead and replace that because, as you'll see later, I'm sorry, this is 2i. I had to take the second one minus the first one. As you see in a minute, it's going to sort of work out that that's not really going to matter. Over I sub 0. Okay, and then if I go ahead and expand this first logarithm, well, first I can combine them into two logarithms, right? I have this subtraction going on, right? So I can factor the 10 out. 10 times log of 2i over I sub 0 minus log I over I sub 0. So what we did is we factored a 10 out of each of these things and we brought it out. And now we're going to work with what's in the parentheses. Now, this is 2 times I, so I could make log of 2 minus log of I divided by I sub 0, plus, because these were multiplied, minus log of I over I sub 0. And you see, these two items are the same, so when I subtract one from the other, they cancel each other out, and I just end up with 10 times log of 2. If I go ahead and calculate log of 2 and I multiply it times 10, then I get 3.01. Okay? So that's how we did it. Now, could I have factored these more? Could I have expanded this more to be log of I minus log of I sub 0? Yes, I could have, but in this case, that wouldn't have really helped me solve the problem. Okay, so as you're using these properties, it isn't necessarily the goal, especially when we're solving word problems like this, it isn't necessarily the goal to just automatically expand it completely. What you're trying to do is use this ability to expand and condense in order to eliminate parts of your problem that are difficult in terms of solving the problem. Okay, so that's 4.5, and then move on to 4.6.